First of all, I must say that it is my honor and pleasure to welcome here at the ACM Professor Marten Scheffer. You are very welcome. First, as far as I know, this is the first time that he visits our institute. Even if last year he already participated giving a conference in the Ramon Margalef course, I guess. But at that time it was online, so he was not here. But I know people that participated in this course and they really enjoyed it. And this time, again, his name is associated to that of Ramon Margalef, since, as you probably all know, this year he has been recognized with the Ramon Margalef Prize, which is awarded yearly by the Generalitat de Catalunya, and it is one of the most prestigious one on the field of ecology at the international level. Especially, I think that most of you know him better than I do, but especially if there is one or a couple of persons here that do not him well, let me remind that Professor Scheffer is a distinguished professor at the Wageningen University in the Netherlands. He has contributed significantly to the development of ecology by his theory of alternative stable states and abrupt shifts in ecosystems, but he has also influenced the way we think about other complex systems, not only in ecology, but also in the climate system or in the society as a whole. He has had a number of brilliant ideas and groundbreaking concepts, and the first is probably that abrupt shifts can reshape complex systems. These shifts represent critical transitions that happen at tipping points between contrasting states, and the work of Professor Scheffer has been key to understand and anticipate these transitions. In particular, Professor Scheffer has showed how catastrophic shifts in ecosystems work, using entirely new work and novel approaches to the protection and restoration of a wide range of ecosystems. A second, and as important as this one, a second groundbreaking discovery has been to demonstrate that it is possible to anticipate these critical transitions using universal principles that are valid across complex systems. I mean, including not only ecosystems, but also these other systems I was mentioning before, such as climate and society. This means that even if we do not understand a complex system, there might be ways to detect if they are close to a critical transition based on universal mathematical laws. The idea that there can be such generic early warning signals triggered an avalanche of follow-up works and a number of publications in journals as Nature and Science and others, demonstrating the validity of this idea. Another important thing is that while these tipping points in complex systems might imply risks of unwanted collapse and others, they can also imply opportunities for positive change. So this optimistic way of looking at these kind of things is another characteristic of Professor Scheffer, and I think it's quite related to the talk that he will give us today. So in summary, Marten Scheffer is a leading and inspiring scientist at the international world-class scientist who always crosses and pushes back the boundaries between different scientific disciplines. So this time, we did not want to miss the opportunity to welcome and invite him to visit the ICM, which is the home of Ramon Margalef during a long time in the past, to know and congratulate him first personally for his career and for the award, and to take advantage of his knowledge and breadth of vision at the crossroad between disciplines, which is particularly interesting and relevant in a multidisciplinary institute as ours, where there are ecologists, but there are also physicists, there are chemists, there are geologists in the same place. The talk that he will give us today, which is entitled Climate Optimism, Pessimism and Hope, as well as the discussion and roundtable that will follow, offers promise to be highly exciting, interesting, and of course inspiring for all of us. So I hope you will enjoy it as it deserves. So at the end, I would like to sincerely thank Professor Scheffer for his kindness in accepting the invitation and being here with us today, especially considering that today is a very busy day and this afternoon he will be in Palau de la Generalitat to receive the award. And I want also to thank Celia Marrasé for having made it possible and organized this event very well. Thank you very much. And that's all from my side. Thank you again and welcome, Professor Scheffer.
Thank you. So I was communicating to Celia, and she said, "Well, I was asking what should I talk about," and she said, "Well, a lot of people here are kind of worried about the world, about the change, and so it would be good to hear what you think about it." So that's how my title came about: Climate Optimism, Pessimism and Hope. But then I realized we have a son of Margalef himself, and we have a lot of history here of Margalef. So now I had two lectures, one for tomorrow at the university and one for here, and and now so I decided today I will combine them in some way, but also keep it open. So for me, the most important thing would be to exchange like thoughts with you and see how you look at things. I'm trying to learn every day about the world as it is and where it is moving, and so I think all the thoughts of that, I'm very interested in it. So when you hear the news, when I read the news, it doesn't really make you happy, right? It's like war here, war there, shooting, but then of course there is one other theme, which is nature being destroyed here, being destroyed there, species going extinct, species being invasions. And then there is the other musical theme that we have. The climate is warming, and it's over and over again in the news. And many of our students at Wageningen University, they're really depressed about it. They really feel very, very bad. And I realize now that the discussion about that problem is now everywhere. So what do we do about it? Because it's not good to feel so sad about it. It's not good because it doesn't feel good. It feels much better to feel happy. But it's also not good because if you think it's so bad, it makes you kind of hopeless, and that's not really inviting for doing something about it. But it's a fine balance, because if you say, well, it's not so bad, how can you say it's not so bad? So I think the key in that is is what I put in the title. You can be optimistic. Now, optimistic is like this. Yeah, it's going to be all right. Feet on the table, right? That's optimistic. You don't do anything. Pessimistic is the world is going down the drain anyway, so it doesn't matter if we do anything. Hope is something very different, because hope is it means that there is a possibility for going in the right direction, but it doesn't happen automatically. It only happens if we do, if we act, if we do something. So I think hope is really important, and I thought I make that a theme, and then Celia and others had seen videos of me doing science talks and then doing a bit of music. So they were like, "Are you going to make music?" I don't know if we're going to make music. But in the end, I brought the smallest two instruments that I have, which is the harmonica and is the ukulele. But it's the smallest ukulele that you can buy. Very small. You can just like slip it into your pocket. So I thought I would be doing a little bit of. Now we can just think about the theme while I play a little bit of dark and then a bit of more light music. So let's first let's start with the dark one, then we can end with the light one. just to relax a bit. Life is already too serious. Science is very serious also. So let me look at my 2 lectures. I have a lot to. I would like to share a lot of things. Yeah. So when I was involved in one kind of doom science thing, which was the planetary boundaries project. We wrote a paper trying to summarize what is the state of the planet, and we looked at different boundaries. How much is safe? How much CO2 in the atmosphere is safe? How much land can we transform and it's still safe? How much phosphorus can be in the environment and it's still, we don't get global anoxia in the oceans? So those were the planetary boundaries, the safe operating space for humanity, we called it, with a group of scientists. And we've just done a kind of an update of that, where we not just look at the planet, but we look at people, and especially the most vulnerable people. So now we call it a safe and just operating space, because you see when there is trouble with the climate or pollution, very often you see that it's not hitting the rich as much as it does hit the poor in the global south. And I was looking back at the planetary boundaries, because I'm going to write a book in the coming month. I hope I will be able to write a book in the coming month. And the working title of the book is Tipping Out of Trouble: How Civilizations Transformed and We Can Do It Again. Basically asking that question, is there hope? Is there a way out? It's a kind of difficult book for me to write, because I think like many of us, when I start writing about the environment, the planet, humanity, I tend to write only grim, kind of doom things. You see only the things that will probably go wrong. So I was kind of forcing myself to go around that a little bit and see the other side. And first I was thinking about the planetary boundaries, and then I thought, well, the planetary boundaries, yes, we have the phosphorus, we have the pollution, we have this one. But really there is only 2 problems for the planet that we have. One problem is the loss of nature, and the other problem is the climate. And basically we also know what to do about it. Because the loss of nature, basically what should we do? We should basically go to a plant-based diet, then we solved most of the problem. And the climate, we should just stop taking fossil fuels out of the soil, and then it's solved. It's not so complicated in a way, but it's something different to know what we should do and to actually see that happening. Of course, it doesn't happen automatically. So. So, first of all, of course, we have to admit that we are in a shitty situation, right? It's not going well. It's not going well with. Let's start with nature. Let's start with the planet, and then we go to the people. So, I've been wondering about the science we do for that. I mean, you can say, well, what is needed? Of course, is a social change. But then you may ask, okay, but I'm a scientist, so what is my role in the whole thing? So one reason for hope, I think, is that as scientists we have an important role to play. You may think that, well, you know, the world is moving in a direction, and the world is a complex adaptive system, and I am just this tiny part in this complex adaptive system. What does it matter what I do? I'm just an ant in an ant colony that I don't have much agency in a way. But then think of George Orwell saying all animals are equal, but some animals are more equal than others, right? I love that. That's fantastic. And of course, some people are more powerful than others. So you may think of Elon Musk and Vladimir Putin, like, oh, they're powerful. But I think there is different kinds of power. There is the power of the kind of a hard power, but there is also the soft power, the power of sense making, making sense of the world, showing what is happening. If we do this, then that happens. Make that very clear. And in this sense making, that's the business that scientists are in. So I think we are ants in a big ant colony, but scientists are a bit different ants. They help making sense of what is happening, and this, if you do this, then you do that, showing the possibilities, showing the options, make scientists a bit different from the average person, and also make us have a responsibility in a way, in that sense. Scientists, and I would say also artists that make movies, documentaries, write poems, they also are important, because there are different ways of science and art making sense of the world, but they're also kind of doing the same thing. They're trying to capture the essence of this very complex thing. There's so many things, but then you try to capture something and make that very clear. That is also what the arts do. So I think artists and scientists do have are a bit different from the average. So I think that's also a reason for hope. For us, we can have an influence. So then let's talk a bit about ecology. So if you think about the science of ecology, I myself I've been studying lakes for a long time, and for marine scientists, lakes are the same as oceans, but very small, so you can, they're easier to study. You can manipulate them even. Of course, Margalef was interested in lakes, in rivers, in oceans, in the things underwater. And he was not the only one of the first ones. Some people say this is the first ecologist. This is the person that started ecology as a science. This is Stephen Forbes, and he wrote an article 136 years ago, and it was called "The Lake as a Microcosm." And that article was so kind of well describing what ecology is about that many people say, well, this is really the start of ecology as a science. 136 years ago, that's just like after Darwin published his main things. And what I would like to, one of the things I would like to do is make a mirror image, like this is 136 years ago. Now let's think from now 136 years in the future. That is the year 2159. So, what will the world look like then, right? And also, what will the children of your children then think when they look back? Like now we look back to Forbes and then to Margalef, and we like a lot their science. So how would our grandchildren look back at our science? Would they say, well, that was really the science that was needed at that moment? Or would they say the scientists were just going like doing the same old things while the world was on fire, so to say? Are we asking the right questions as scientists? So I come to that later. But first let's see, why is this such a famous article? I have to read it. He writes, for instance, he writes about a lake. He is looking at the lake, and he takes the reader to the lake where he sees all the crustaceans and the phytoplankton and the temperature in spring going up, and then the river flooding the lake, and then the river going back. And he observes what is happening, the dynamics in the lake. And he writes, a lake forms a little world within itself. It's like easier than an ocean. It's so small you can really, it's like an aquarium almost. A microcosm within which all the element forces are at work. So a microcosm is the world in a nutshell, right? You see everything like the world is working, but in a very small place. It's like the magic you see in an aquarium or a terrarium. And he writes, the play of life goes on in full, but on a small scale, as to bring it easily within the mental grasp. So that's the microcosm idea. All the processes we see in the big world, you can see them in a small world. Nowhere can one see more clearly the impossibility of studying completely any species out of relation to the others. Well, that's the idea of ecology too, right? So you can't really, you have to understand the whole. You have to look at the holistic thing. Very much Margeleff also, of course, to look at the whole. And what people don't realize when they read the article is actually how it ends. And I want to show you that. Because he makes a connection to human societies, very explicitly. He says, in this lake, where the competition is fierce, where mercy and charity and all of the virtues are utterly unknown. It's all evil, right? So the lake, everything is everyone is fighting and eating each other. Where robbery and murder and the deadly tyranny of strength are the rule, like that's nature, it's full of, everything is negative. Even here, out of these hard conditions, an order has evolved. I said, look at it, nature is a beautiful equilibrium, even though everything is bad. We know, of course, now not everything is bad. We have facilitation in nature and all that. But he was like making that point. And then he moves to human society. And then he says, if the system of life is such, may we not trust much to the outcome, where, as in human affairs, the adjustments of nature are aided by intelligent effort, by sympathy, and by self-sacrifice. So he's very optimistic. He says society is like nature, but it's better than nature, because in nature everybody's just killing each other, and in society we are also like, we have self-sacrifice and you may it sounds very naive, and maybe it is a bit naive, but I love the idea that you can look in a lake, you can look at the rules we have, the balances, the cycles, the chaos, all the mechanisms, and then think about society, and you can actually learn something about society. I actually think that biologists, ecologists are very well placed to start thinking about humanity and the future of humanity, because ecology is a special science in the sense that we like to look at patterns, try to understand the patterns, but we also like to do experiments, controlled experiments in the lab. We like models, we make simulation models. We accept all those different tools to make sense of the complex system. That's not the case in all sciences. Some sciences, they just go for the models, and others just go for the patterns, never do an experiment. And ecologists are pretty much all round. We have a good toolkit, I think, a good toolkit for thinking about the world, and it kind of gives us a license to think about broader, but also about humanity, I would say. I have moved a lot from studying just the lake to trying to understand humans, and working together with people on those themes. So if you think of what came after Forbes, so it was a generation of towering figures, and Margeleff was definitely one of those. When I was studying ecology in Wageningen University, of in Utrecht University, it was one of the basics that they were teaching to me. And my wife here, Milene Holmgren, studied ecology in Chile and in Mexico. And in Mexico, she did her university studies. And they were all using the book by Margalef, which was at that time the only original ecology book in Spanish. And many of the students then they were not able to read in English. So he has also influenced a large part of what is now a generation of ecologists in Latin America. But Margalef, of course, he was not alone. There were people like old men, Evelyn Hutchinson. The name I always think sounds like it's a woman, but it's not a woman. It's a man. Hutchinson was studying lakes also. He was famous studying lakes, thinking about biodiversity. Gleason, studying vegetation patterns. We have Charles Elton, who's an animal ecologist. Robert MacArthur, famous theoretical ecologist, died very long, but wrote about island theory, very important ideas. This whole generation, they're really giants. They really developed the fundamentals of ecological thinking. If you think about theories, general theories in ecology, they were all basically developed then. Not so much happened after. Of course, a lot happened after, and we got a lot of Margalef prizes for what happened after. So that is somebody made that as a portrait of me at the university. But so think of the birds as all the generation of, like my generation, I would say, after Margalef, so to say, we have basically been developing the same themes further. Doing smart experiments and doing some smart mathematics and so. But the real basic ideas were already, I think, put forward. So I think it is actually now is a good time to change. I sometimes go to the conference, the annual conference of the biggest conference in ecology is the ESA meeting, the Ecological Society of America. It's huge. It's like 4,000 people always, and then I think, oh, this will be exciting. It's not so exciting. It's the same thing. I mean, it keeps going on, showing this, showing that, the same kind of thing. So I would say it is time to think about what are the questions we ask, because the world is changing. This is a picture of how the world is changing, and I will explain this in a bit more detail later. But we know that something has changed. When I studied ecology, no one was talking about climate change. For instance, it was happening, and some people knew it was happening. Like the scientists of ExxonMobil, they had already computed pretty well what would be happening to the climate in 1970. We now found those reports. But of course, ExxonMobil didn't share it with the world because they thought that would be a very good idea. Instead, they emphasized that there was no problem. But anyway, amongst us as scientists, it was not a theme at all in the 70s, in the 80s, even in the 90s. Not so it has rapidly become a theme, and it has become perhaps the theme. Of course, the loss of habitat and the climate change. But as science is always, the way it works is it's very difficult to put a new question forward. But when people accept, well, this is a really important question, like whether tipping point exists, or whether competition really exists in nature, this kind of things. Then they keep going endlessly, or whether chaos can be proven to exist in an ecosystem. Then you get so many papers and experiments and everything about that same question. It's very difficult to move to a new question, because if you want to publish a paper that is accepted by the big journals, it should be a paper about a kind of big classical question that you have the best chances. So that kind of creates a slowness in ecology. So I was last summer I was asked to open the International Ecology Conference, INTECOL, in Switzerland, and I thought let's think about what should be the questions for the future of ecology. What questions should we ask? And I don't know the answer, but you can imagine if the world is changing so fast, then questions you might be wanting to ask the questions. If we're going to the next mass extinction, losing like a quarter of or half of the species on Earth, what do you want to study, or what do you want to do? Do you want to think about how you can, for instance, how quickly evolution can adjust to climate change, whether you should think about ways to aid rapid evolution? Of course, evolution is potentially a very fast process. I think it just doesn't happen too much, because no species can move nowhere. All the niches are kind of filled. So if you relax that constraint, you put, for instance, one fish in a lake that appears in Greenland when the ice retreats, in very few generations, this species diverges into different species. Potentially, evolution is fast. Should we think about fast evolution in a rapidly changing world? Is that what we should think about? Or if we are worried about the functioning of ecosystems, should we think about like species replacement as you get migration to different places? Should we assist the movement of species to new habitats? You can think of species going north, or going up the mountains, or in the ocean, the warm and the cold water areas. How are they divided? Should we think about when there is kind of invasive species? Might they actually be helpful for keeping the functioning of an ecosystem in a changing world? I don't know. I'm just thinking that when you look at ecology, you see a lot of conservation ecology, restoration ecology. So conservation and restoration, they're kind of backward-looking principles, and at some point you can't just restore, because you will never have the same thing. The world is changing, so maybe we should think about a new world. So that is one question I had, and I thought it would be nice to chat a bit about what would be questions that are not just questions about what's going wrong and showing what is going wrong, but also kind of forward-looking. Can we help think about the world of the future? And the other is like thinking about humans as an ecologist. So this is an example of how I started thinking about humans as an ecologist. So you look at the early ecology, and one of the first things, the ideas is niche. That species have a certain niche, a certain whatever, pH or nutrient values or temperature or oxygen levels that they're restricted to. The physiological niche or the ecological niche, that's very well accepted and studied. So then I was at a conference with Milena in Mérida in Mexico. It was a conference of tropical biology, and it was in the tropics. And outside the air-conditioned conference hall, we had rented this little kind of cabana, and I was thinking, how can people live in this climate? It was humid, it was hot, I could hardly think. I think, is this good for humans? What is the human niche when it comes to the climate? And I start Google. I couldn't really find anybody doing that. Well, yeah, there is this like dangerously high temperatures, the wet bulb temperature where you die or so. And I thought, there was very little. There were like some papers showing that if it's too hot, you can't concentrate well, or you become more aggressive, but nothing really overarching. So we came home and we got a friend from China visiting, Xu Xi, that we have been working, both Milena and I have been working many years, as a fantastic scientist, and he just came to visit us last week, and that was after actually 3-4 years because of COVID, we couldn't move, and then because of difficulties of exchange, it was very difficult to get a visa to leave China because the Chinese don't trust the Chinese that leave the country, and then to get into Europe because the Europeans think that all the Chinese that come to visit us are trying to spy, and so it's not becoming easier. But he was there, and with Xu, then we thought, okay, what would be a nice research project, because he was coming to spend his sabbatical with us. And then, just coming back from the heat in Merida, I thought, maybe the human climate niche. Let's do like just ecologists do, which is plot the temperature and the rainfall, and then we plot where most people are. And a beautiful bell-shaped curve came out, just like for animals, as we know. So this is interesting. It could be a coincidence. So let's look where the people lived in the medieval times, in the climate then. Same temperature distribution. Then we went back to like 6,000 years ago, the reconstructions of where people lived, and it was the same kind of. It was centered around like 14 degrees Celsius mean annual temperature. So that's the mean between winter and summer and between day and night. And still we were not sure, but then a paper came out from economists, and they were studying for each country the economic output. Some years were hotter and other years were colder, and then they saw that whenever the mean annual temperature started deviating from this 14 degrees, the economic output went down, and not only from agriculture but from everything. So I think in the end we have good evidence that humans function best at certain temperatures, and of course the rainfall also matters. So then we thought, okay, let's think about the future of the human climate niche, and we took the climate projections and run them forward 50 years and then 100 years, and we looked where the best place for humans on the earth was. So the bad news is that in all the red places, it's becoming worse for humans. They're going to fall out of the human climate niche. But there is also good news, which is the green places, which are places that are becoming better for humans. It's not that the planet becomes unlivable, it's just that different places become better. So if we would have to stay within the niche that we have stayed for thousands of years, despite the fact that since 6,000 years we've become better at clothing, airco, heating, moving, but we didn't change our distribution relative to climate. If we want to stay within the same climate niche, we can do that. It means that around 1/3 of humanity would need to move, and then we are in the climate niche. So it's not that the climate becomes impossible for humans, but different places become better. So, of course, we have to try to prevent climate change from going on. We have to put all force in slowing it down and bringing it to a halt and eventually reversing it. But who knows how fast that will happen? We have an electric car, but does that help? We're recycling the plastic, but is it enough? It looks like it's all. There are many initiatives, but we all know there is too much bullshit. There is too much greenwashing and we-washing. We are going to, and not so much is moving. So maybe we're too slow. I think we are slow. I think we will solve it, but maybe we need a century or 2 or 3 to draw down the CO2 levels. And meanwhile, it looks like it could be necessary to also redistribute people. I wanted to be minimalistic, like everything small, so I didn't even put a citation. But if you want to look for it, the paper is called "The Future of the Human Climate Niche," and then from there you can find more material. So then, if you think, what is the science that we need to facilitate the future? Then also you get to different questions. You get to, of course, political economy questions, asking how can we facilitate? Because people, if you look at nature, species are moving, and in the past humans were moving when the climate changed. That has happened over and over again. But since quite recently, like 100 years, we have nation states and borders and passports. It's a new phenomena, but it makes it quite difficult to simply move. Like the adaptation that you see in many organisms. So how can we facilitate that? That will be one question, because many places are actually, many countries are looking for more people. Germany is looking for more people, and they have this new point system in passports for which kind of people they want, which kind of workers they want. Canada is planning for expanding its population 4-fold because they don't have enough workers. Many countries have graying populations, and especially if the climate becomes better and you want to take advantage of that, you need to work the land, you need to plan, you need to make infrastructure for that. So that looking forward is important in that sense. In a political sense, how do we make that happen globally? What are the costs? What are the benefits of having people moving? Of course, also you need to change the whole food system, because now a lot of the food is produced in the global south. A lot of it is produced for local consumption. When that changes, what does it mean? So what would be the ideal food system if the green areas would become major food producing areas, without repeating the errors that we have made in the intensive agriculture now, which are kind of basically ruining the soils and the environment? How can that be changed? How can the food system be changed? And in part, we also need to change, of course, the diet. We need to move to a more plant-based diet. And it's not enough in general to leave that to the people, because the choices that the people make depend very much on what they now call the ecosystem. So it's the environment that you're in. It's the choices that you have. It's the prices of the meat, the price of the vegetables, the price of the plane tickets, the price of the train tickets. And there was a beautiful paper recently showing that at this moment the governmental funding in Europe and in the US for kind of developing and promoting animal-based projects is 1,300 times larger than the government money that goes into developing and promoting plant-based diets. And that's not a coincidence. There are, of course, big forces that are benefiting from the status quo. This is true for the fossil industry, it's true for food production. So what are research questions then? Research questions are like unraveling that, showing how it works and making that very clear, and then asking what would be real ways to move forward, not just to say, well, and everybody has the option to eat a carrot or a steak. No, it's too easy like that. There is something in the system that needs to change too. And as scientists, we can help thinking about what are the barriers and the ways potentially forward. And then, of course, a third major obstacle, like one was like migration, the other is like the new food system and infrastructure. A third one, of course, is culture, because it's not so easy to do the cultural integration to make everyone live happily together if you are looking at such movements over the world. And again, there we have the social sciences. We have lots of very interesting studies of places where things worked out very well and places where things went very wrong. So I think I'm hopeful about the future, because there are so many options and there are so many things, and I'm also hopeful for how we can feel as scientists, because all of those things basically they require thinking about what are the options, but they also require like thinking in new ways, thinking, not sticking to the old questions. And so sometimes I wonder if Forbes and Margalev would be here and they would know what we know and see the change they see, how they would look upon that. They were very innovative thinkers, radically different from what was before. And we are standing on the shoulders of giants. But if the giants would be here with us now, they would be also looking for new questions. So what is it that we should think about? How can we think of new theories, of new ways forward? So I would like that to leave to you as questions, and maybe we can spend the rest of the morning kind of chatting about that. And thank you.
Sí, sí.
Yes.
Well, we have 10 minutes for questions, and then we will go to a coffee. And then after the coffee, there will be a discussion session. But if some of you want to ask a question, Xavier?
I have a question about this map that you showed. Sure. So I have a question about, I have two questions about the map that you show. First of all, I think it's an unfair, it's a map that shows war. It shows war. If you project it in the future and you consider the reality, it shows war, because it means displacing people from the global south to the Western world. It's what it shows. And that, for me, it goes beyond science. So it goes beyond science because it reflects a situation where we have been neutral about stopping climate change. Everything evolves to this situation, and we can keep being neutral scientists, providing solutions for a mess that we allowed and we as Western scientists created. So I don't see a lot of hope in this map. So I was wondering if you excluded the fact of war and conflict from your projections purposely from a neutral scientific perspective, or was just that you ignored that fact? For your optimism regarding this map.
Yeah, thank you. Well, first of all, this is not a map of war, and it's not a map of migration either. It is a map that shows the value of the level of a niche which is computed from past distributions. So we computed it for 6,000 years ago, for 2,000 years ago, from the Middle Ages, and for now. And we have different versions of it, and we have a version where we took into account the mean annual precipitation or not, temperature and not. And this is just, it's a niche projection, or to be more precise, it's the difference between the value of the empirical niche between now and climate projections, and we have many versions of that. So that I would call science. I am not talking about war. This is just mathematics. This is just ecology applied to humans. And in this paper, the future of the human climate niche, and in the newer version where we update, the newer version is called the human cost of global warming, and there it's also still science, so to say, in the sense that now we have a lot of computations of the cost of a ton of carbon in terms of loss of agriculture, sea level rise, and so. And we thought that it is missing some of the points. And because of that, we were kind of computing the costs of a ton of carbon in terms of persons displaced over a century. So that is a more recent one that you could look up. It's still all very much science. And in both papers, we write, we will not say anything about migration, because migration is a very complicated process that you can't really predict. Nobody wants to move from the place they're in. You want to stay as long as you can, and only if it is really impossible, you will move. And when you will move, that will depend on how you see your options, and that will depend on what you hear from others that have moved. And we won't go into that. So that this is, so to say, we didn't go into any of that. But now I must say we have an opinion paper in press that will come out, I think, the coming month. And the title of that is Anticipating the Global Redistribution of Capital and People. And it talks about the patterns that we see now. And the patterns includes also the redistribution of capital, because if you look now who owns the buildings in London and who owns the land in Africa, and so it's not only the local people, and it is moving, anticipating changing conditions. And we put forward this research agenda where we ask to look for win-win situations of how you can adjust by migration. Now, your point about war and conflict is a very good one, because there is a very clear correlation between, for instance, hate tweets and the temperature. That's also science. It's a correlation. Maybe the hate tweets cause the temperature in the country to rise, but probably it's reversed. It's a strong correlation. And also global conflicts. In the beginning, it wasn't so clear whether like heat waves or droughts were actually causing the conflicts. And the reason is that attribution is difficult. it's also difficult to attribute a drought to climate change because it could happen anyway. So this is a kind of matter of just looking at the chances of it happening increasing. Well, the chances of conflict are increasing a lot when people are in trouble, when there is no food, and also when the temperature rises. So I would agree, and we have other work in progress. And again, it's science. It's not speculation. It's just looking at the patterns showing the risk of violence. And then we do all the computation, the number of people that died, the number of conflicts divided by the number of people, and all those statistics, relating them to changes in the weather, to changes in the climate. And we find them happening more often at the edge of the human climate niche, so to say. So if we do nothing, I would say we are waiting for trouble. There is a very strong tendency for people to say we shouldn't say that the global south becomes unlivable, because then we're asking for trouble, then the right-wing nationalists will all close their borders and the world will end in a terrible place. I think that's a very wrong reaction. I think we should face reality and then look how we can make a win-win situation as well as possible out of that. And actually receiving migrating people can be a win-win situation, but only when it's done well. So I see where you're going, and I think you're right, but I think we need to face this discussion.
Yeah, this planet, in addition to the climate change, has another big problem, I think, which is overpopulation. Human population keeps increasing, and seems that there is no stop. No, about 20 years ago, it was thought that the carrying capacity of the Earth was between 9,000 and 15,000, around 15,000 million people. So we are, according to the UN projections, we are arriving at that point, no, in the next 50 or 100 years. So what's your opinion about the carrying capacity of the Earth under current conditions of like the people like to live? That's one question I would like to ask you. And then the other one is like, the organisms have basically three ways to adapt to climate change. You know, one is to genetic assimilation, and the other one is to range shifts, or like the niche displacement, and the other one is phenotypic plasticity. So in the case of humans, let's take away genetic adaptation because change is too fast. So, and range shifts, you already showed your projection. So what about phenotypic plasticity in humans? A lot of people just study phenotypic plasticity in many animals, but I don't see studies on humans. Is there anything going on that aspect?
I don't know about the phenotypic plasticity. Of course, there is behavioral plasticity. And so if people that live in a very hot place, they just don't go out like we do jogging at noon for 5 kilometers, and so you live differently, and there is a lot of plasticity in that. I think there is also a limit to the phenotypic plasticity. Like there is basically a limit to the local adaptation. The same as we see in nature, tropical rainforest, when you reduce rainfall, the forest adjusts. You get different species that are more adapted to drier conditions, but there is a limit to that. At some point, you just can't be a tree under that condition, and it changes, and you get the savanna state. The same for, I would say, probably coral reefs or other major biomes. There is a lot of plasticity, but it doesn't mean there is no limit to it. And then the other question about the carrying capacity of the Earth. The carrying capacity of the Earth it's very difficult to relate to just think of that in terms of the number of humans, because the ecological footprint of the average person in Ethiopia is 70 times smaller than the one in Holland, I just heard. So it depends a lot on the lifestyle of those people. And if you look at the dynamics of the number of people over time, how they change, at the moment we are still seeing a small global increase in people, but in most places we see a decrease. It's mostly sub-Saharan Africa and India where there is still an increase, a strong increase, but most countries face a decreasing population, like China and Japan, but also Europe and many places. Overall, there are changes, but the major. So if I get one child in Holland, that is just as bad as somebody in Ethiopia getting 70 childs. So that's a huge variation. So in a way, the consumption pattern is way more influential than the number of people. So I would say the worries for the future of the Earth have more to do with the consumption pattern at this point than the number of people. And probably the number of people will, in the long run, go down. But the key to the pressure we put on the planet is more in the consumption than in the numbers. Yeah.
The last question. Oh. We can leave more questions after the coffee, but we take the last one.
Yes, I was wondering about this map you put about which areas are going to have a niche which is going to be more suitable for humans. Have you considered that it may be not so important the niche itself, but the rate at which the niche itself changes? Meaning that the areas who might be more suitable for life, for humans, might be those areas in which the environment changes, but changes more slowly. Because it takes some time for the environment and for humans to adapt to change. So maybe it's not so much the final environment, but how fast it changes. And which map will you get then?
Yeah, no, that's a great point. I think that is people often forget that sometimes the rate of change can be more important than the absolute change. So it's about the time you have for adapting. So a lot to say about that in a more general sense. Like if you now we're in ocean physics and environment. If you the influx of fresh water in the northern hemisphere. Like the rate at which you get the water is more influential for the kind of blocking the thermohaline circulation than the absolute amount that goes in. And there's so many more things you can think of physical systems like that, the rate of warming in permafrost, and of course the rate of change and the possibility for adaptation of species and of humans. So I think that's a great point. And in a sense, the difficulty now is that climate change is, as we see it, is happening faster than we can see it happening in anywhere in the past. It's a bit difficult because we can't have the temporal resolution of the geological record often to show how sharp it was. But it looks like the rate at which we see change now is really very fast, and that's one of the main problems. I think that's a great point, and that's in a sense it has been a blind spot in a way for at least in ecology to look at things, and maybe also in social sciences. So yes, important point.
So we can move now to the coffee. It will be in the patio, in the central patio, in the first floor, and then we'll come back at 12 here again for discussion. Thanks.